In this video, we'll be learning how to write better unit tests with test data builders. This is part 5 of test-driven development in Unity, but don't worry if you aren't caught up, because I'll be giving a quick overview of where we're at. Test data builders are factory classes that use the builder pattern to create data for your tests. Adding these babies to your test suite will make your tests more maintainable and much easier to read, and creating them is as easy as following a simple set of guidelines. But before we get into the code, let's do a quick recap. Heart containers contain a list of hearts, where each heart represents a unit of health that is measured in heart pieces. Full hearts have 4 heart pieces, and empty hearts have 0. A heart calculates the number of heart pieces it has using the fill amount of a Unity UI image. Each 25% increment of image fill equals 1 heart piece, so a heart with an image that is halfway filled has 2 heart pieces. Health containers should replenish their hearts in order, from left to right. This test verifies that behavior by calling replenish on a heart container with 2 empty hearts, and then asserting that the second heart remains empty. It uses 5 objects: the heart container, the 2 hearts, and their images, all of which are created directly in the test code. This is fine for a couple of tests, but the code will become much harder to maintain as the test suite grows. Imagine if we had 4 more tests just like this one. We'd be creating a total of 10 hearts. If we decided to change the heart class's constructor, we'd have to refactor our test code 10 times. Test data builders encapsulate object creation, so we don't have to worry about that happening. We could create hundreds of hearts, and we'd still only need to refactor the test data builder that created them. Plus, on top of that, the tests become much easier to read and clearer to understand. Alright, let's write some code. We're going to work from the bottom up, so let's create a class called ImageBuilder. I like to keep all of my test supporting classes together, so we'll stick this into a folder called Infrastructure. Now, according to the guidelines, the first thing we need to do is create an instance variable for each of Image's constructor parameters. Image doesn't have any constructor parameters, but we'll need to set the fill amount property pretty often, so let's create an instance variable for that. Next, we need to provide a safe value for fill amount, so we'll use constructor chaining to set it to 0 by default. Moving down the list, we'll add a method called build that returns a new image. Unity UI images are mono behaviors at their core, so we'll need to create a new game object. Then, we'll call add component to get an image, and then set its fill amount. We'll set this value using the instance variable on ImageBuilder. Last but not least, let's add a method called withFillAmount that'll let us set the image's fill amount from the test code. This method should return the image builder so that multiple with methods can be chained together. This is useful when an object has multiple variables. But in this case, image only has the one. At this point, the test data builder for image is complete, but we still need to expose it, so let's create a static class called un. By introducing a method called image, we'll be able to get a new image by literally calling unImage. Adding this to our test code is going to be a hell of a lot of refactoring, so for now, we'll just tackle a single test. This one uses 2 images. The first one is created right here in the test method, and the second one is instantiated in the setup method. Alright, let's run the test to make sure we didn't break anything. Awesome. It's already starting to look good, but I don't like having to call build on every image builder, so let's introduce a little bit of magic. I'm going to add an implicit operator so we can cast image builder to an image. The trick will be to call the build method whenever we perform the cast. This results in an interface that is clean and reads clearly. Again, we'll run the test to make sure that everything is still working. With that, we can get to work on the heart builder. Following the same guidelines as before, we'll add an image instance variable, since heart takes one on its constructor. Then, we'll set a safe default value for image using the image builder that we just created. This will work without calling build, thanks to the implicit operator we added to image builder. Next, we'll add a build method, which will instantiate a new heart, passing the image instance variable into the constructor. We'll need a way to set that image instance variable, so we'll add a method simply called with to take care of that. If heart had more constructor parameters, I'd override the with method with different argument types. But for now, it only has one, so this is all we need. We'll finish off heart builder with an implicit operator, so the tests remain nice and clean when we refactor them. Now, I'm a stickler for grammar, so I'm going to expose this builder on a class called A. That way, we can retrieve new heart objects by calling aHeart. Let's add this into our tests. I see two hearts that we can replace pretty easily. And I can actually get rid of this temporary image variable too, since hearts are instantiated with an empty image by default. Alright, let's run those tests again. Still green. Now that is a clean looking test, and we haven't even created a builder for heart container. But before we do that, I've got an itch that needs scratching. Placing these two builders side by side, I'm seeing some duplication that I'd like to extract into an abstract class. Normally, I'd use ReSharper for this, but this will be a little more complicated, so I'm going to do it by hand. This abstract test data builder class I've created takes one type parameter that it'll use for the return value of build and the implicit operator. Build will be an abstract method that each builder will have to implement. But we can actually implement the implicit operator right here in test data builder. This is thanks to that type parameter. Now, let's refactor image builder and heart builder to inherit from test data builder, overriding build and removing the implicit operators from each of them. And of course, we have to rerun our tests again. Great. Let's skip ahead now. I've created a builder for heart container and refactored all of the tests to use test data builders. As you can see, our tests have become much easier to read. But more importantly, the test logic is now completely decoupled from the test data. We've gone from having to refactor our test code n number of times to only once every time we refactor one of our domain objects. That's pretty significant and goes a long way towards increasing the maintainability of your test suite. We're going to see this firsthand very soon because completing the heart-based health system will require us to convert the heart class to a mono behavior. But that'll be later on in the series. For now, thanks for watching. If you'd like to learn more about test-driven development, then head on over to part 1 of this series called TDD in Unity. Or if you're interested in how to unit test Unity code, then I've got a video on that as well. And as always, if you enjoyed this video, then please like, comment, and subscribe. Thanks for watching. Catch you later.